In the previous video, we have learned about the cells have been placed correctly in the cell holders. Now we can move on to the software configuration and program creation process. The software used to control this machine is the cell testing application. This software allows us to create testing programs, monitor all channels in real time, record testing data, and export the final results after testing is completed. To begin, we first open the application. After the software launches, we need to establish communication between the computer and the testing machine. For that, click on the Connect option and then select the communication port that is connected to the machine. Once the connection is successful, all 8 testing channels become visible on the screen. Each channel displays important information such as cell voltage, current, capacity, testing status, and program progress. Different colors are used to indicate different operating states such as charging, discharging, idle condition, and completed status. This allows the operator to easily monitor all channels simultaneously. Before creating the testing program, it is important to refer to the cell datasheet. The cell used in this demonstration has a nominal voltage of 3.2 volts and a rated capacity of 15 ampere hours. The maximum charging voltage specified in the datasheet is 3.6 volts, while the discharge cutoff voltage is 2.5 volts. For cell datasheet, click on the link given in description. As per datasheet, the testing current selected for this demonstration is 0.2 C. Since the cell capacity is 15 ampere hours, a 0.2 C rate corresponds to 3 amperes or 3000 milliamperes. Therefore, all charging and discharging currents used in this program will be set to 3000 milliamperes. Now, we are ready to create a new testing program. From the Step menu, click on New and create a new program. Enter a suitable program name and save it. Once the program is saved, we can begin adding the testing steps. The first step is the discharge process. We select constant current discharge and set the discharge current to 3000 milliamperes. The cutoff voltage is entered as 2500 millivolts or 2.5 volts. This means the machine will discharge the cell at a constant current of 3 amperes until the cell voltage reaches 2.5 volts. This initial discharge step helps bring all cells to a common starting condition before beginning the capacity test. After the discharge process, we add an idle step. The idle duration is set to 30 minutes. This resting period allows the cell voltage and internal chemistry to stabilize, improving the accuracy of the next charging cycle. Next, add the charging step. Here we select the CCCV charging mode. The charging current is set to 3000 milliamperes and the charging voltage is set to 3.6 volts, which is the maximum charging voltage specified in the datasheet. During this process, the machine first charges the cell using constant current mode. Once the voltage reaches 3.6 volts, the charger automatically switches to constant voltage mode and continues charging until the charging termination condition is reached. This is the standard charging method recommended for lithium-ion cells. After charging is completed, we again add an idle step with a duration of 30 minutes. This resting period allows the cell to stabilize before the next discharge cycle begins. Now add another constant current discharge step. The discharge current remains at 3000 milliamperes and the cutoff voltage remains at 2.5 volts. During this discharge process, the machine measures the actual discharge capacity of the cell, which is one of the most important parameters used for cell validation and grading. At this point, one complete testing cycle has been created. The cycle consists of discharge, idle, charge, idle, and discharge operations. For accurate capacity measurement and reliable performance evaluation, a single cycle is not sufficient. Therefore, the same sequence is repeated for a minimum of 3 complete cycles. Throughout all cycles, the charging current, discharging current, voltage limits, and idle durations remain the same. Repeating multiple cycles helps stabilize cell behavior and provides more consistent and reliable capacity results. After completing the 3 cycles, we add the final conditioning step. In this step, the cell is charged back to its normal operating condition. The nominal voltage of the cell is 3.2 volts, and the charging current remains 3000 milliamperes. This ensures that the cell remains in a safe and usable condition after testing is completed. Finally, we add the stop step. This indicates the end of the testing program. Once all programmed steps have been executed, the machine automatically stops the testing process. The program is now fully configured and ready to run. Before starting the test, we verify all parameters including current values, voltage limits, idle durations, cycle count, and channel assignments. After confirming all settings, the program can be assigned to the required channels and the testing process can begin. Once the test starts, the machine automatically performs all charge, idle, and discharge operations according to the programmed sequence while continuously recording voltage, current, capacity, energy, and cycle data for each channel. Once the testing is done, we can observe the analysis of each channel and all the entire channels. And as slow, we can export the cell testing reports for future use. This completes the program creation process for the 8-channel cell capacity testing machine and prepares the system for accurate cell capacity testing and analysis.